Hello students, as per guidelines of Punjab School Education Board, class plus 2 science September paper 2023 chemistry subject ਦਾ ਪੇਪਰ ਜਿਹੜਾ ਹੋਏਗਾ ਉਹ ਸਾਡਾ 70 ਮਾਰਕਸ ਦਾ ਪੇਪਰ ਹੋਏਗਾ। ਸੋ ਇਹਦੇ ਵਿੱਚ ਪੂਰਾ ਬੋਰਡ ਦੇ ਪੈਟਰਨ ਨੂੰ ਫੋਲੋ ਜਿਸ ਤਰ੍ਹਾਂ ਪੇਪਰ ਦਿੱਤਾ ਹੋਇਆ ਉਸੇ ਤਰ੍ਹਾਂ ਕੀਤਾ ਗਿਆ ਹੈ। ਸੋ ਸਟਾਰਟ ਕਰਦੇ ਹਾਂ ਆਪਾਂ ਸੋਲਵ ਪੇਪਰ ਕੈਮਿਸਟਰੀ ਦਾ। ਫਸਟ ਕੁਐਸਚਨ ਜਿਸ ਤਰ੍ਹਾਂ ਸੈਕਸ਼ਨ ਏ ਦੇ ਵਿੱਚ ਪੈਸੇਜ ਬੇਸਡ ਕੰਪਰੀਹੈਂਸ਼ਨ ਪੈਰਾ ਬੇਸਡ ਕੁਐਸਚਨ ਹੈ। ਜਿਸ ਤਰ੍ਹਾਂ ਪੈਰਾਗ੍ਰਾਫ ਹੈ ਇਹ ਸਾਡੇ ਕੋਲ ਜਿਸ ਤਰ੍ਹਾਂ ਫਾਈਨਲ ਪੇਪਰ ਦੇ ਵਿੱਚ ਵੀ ਬਾਇਓਮੋਲੀਕੂਲ ਚੈਪਟਰ ਦੇ ਵਿੱਚੋਂ ਕੰਸੀਡਰ ਹੋਏਗਾ, ਇਸੇ ਤਰ੍ਹਾਂ ਇਸ ਵਾਰ ਵੀ ਇਹ ਬਾਇਓਮੋਲੀਕੂਲ ਚੈਪਟਰ ਦੇ ਵਿੱਚੋਂ ਲਿਆ ਗਿਆ। ਜਿਸ ਤਰ੍ਹਾਂ ਪੈਰਾਗ੍ਰਾਫ ਹੈ, ਕਾਰਬੋਹਾਈਡਰੇਟਸ ਆਰ ਕੈਮੀਕਲੀ ਡਿਫਾਈਨਡ ਐਜ਼ polyhydroxy aldehyde or ketone or compound which produce them on hydrolysis. In layman terms, we acknowledge the carbohydrates as sugar as a substance that tastes sweet. They are collectively called as saccharides and Greek saccharin, sugar meaning, and depending on the number of constituting sugar unit obtained upon hydrolysis, they are classified as monosaccharide 1, oligosaccharides 2 to 10 unit, and polysaccharides more than 10 units. They have multiple function. They are the most abundant dietary source of energy, and they are structurally very important for many living organisms as they form major structural component. Example, cellulose is the most important structural fiber for plants. So question discuss करते हैं। फर्स्ट क्वेश्चन है, डिफाइन द टर्म कार्बोहाइड्रेट्स। कार्बोहाइड्रेट्स it is defined as the polyhydroxy aldehyde or ketone or compound which produce them on hydrolysis. Second one है, write the classification of carbohydrates and they are classified as monosaccharide, oligosaccharide and polysaccharides. ठीक है, 1 unit है monosaccharide है, 2 to 10 है oligosaccharide है, more than 10 unit है then that is a polysaccharides. Next, I define the term polysaccharides. The number of constituent sugar in polysaccharide is more than 10 units considered, that is a polysaccharides. And give the use of carbohydrate. They are the main source of energy for your body and cell, tissue and organs. Next, why the carbohydrates are structurally very important? Because the living organism as they form a major structural component, example cellulose. So ਇਹ ਸੀ ਸਾਡੇ ਪੈਰਾਗ੍ਰਾਫ ਬੇਸਡ 5 ਕੁਐਸਚਨ। ਇਸ ਤੋਂ ਬਾਅਦ ਨੈਕਸਟ ਹੋਣਗੇ ਮਲਟੀਪਲ ਚੋਇਸ ਕੁਐਸਚਨ। ਠੀਕ ਹੈ, ਉਸ ਤੋਂ ਬਾਅਦ ਸਾਡੇ ਕੋਲ ਟਰੂ ਫੋਲਸ ਕੁਐਸਚਨ ਹੋਣਗੇ। ਠੀਕ ਹੈ ਜੀ। ਸੋ ਨੈਕਸਟ ਸਟਾਰਟ ਕਰਦੇ ਹਾਂ ਮਲਟੀਪਲ ਚੋਇਸ ਕੁਐਸਚਨ ਦੇ ਵਿੱਚੋਂ। ਫਸਟ ਹੈ, ਕੋਲੀਗੇਟਿਵ ਪ੍ਰੋਪਰਟੀ ਅਮੰਗ ਦਾ ਫੋਲੋਇੰਗ ਇਜ਼। ਫਸਟ ਆਪਸ਼ਨ ਹੈ ऑस्मोटिक प्रेशर, सेकेंड बॉइलिंग पॉइंट, थर्ड वेपर प्रेशर, फोर्थ दैट इज ए viscosity. And the colligative property, as we know that we have the read the 4 colligative properties: relative lowering vapor pressure, elevation in boiling point, depression in freezing point and osmotic pressure. So option A is correct answer, osmotic pressure. Second, the unit of mole fraction is mole fraction, that is denoted by symbol X. Number of moles of one component divided by total number of moles, and it has no unit. So first option है mole per unit, second है mole, third है unitless, fourth है none of these, and the correct answer is unitless. ठीक है जी। Now third question, isotonic solution are isotonic solution having, as we know in the solution chapter, isotonic solution are the solution having the same osmotic pressure, same number of moles. And first option, let's see the option, same boiling point, second is same vapor pressure, C option है, and same melting point and some same osmotic pressure. ठीक है, and the correct answer that is a D option, same osmotic pressure. Next है the molality of a pure water, that is a option A 55.5, second है 50.5, C option है 18 and D option है 60.5, and the correct answer that is a 55.5. so इन्हों ਆਪਾਂ कैलकुलेट करके देखते हैं। so molality है, the formula it is defined as number of moles of solute divided by weight of solvent in kg, or gram if we consider the gram, then multiple by 1000 multiple. As we know the density of pure water, that is 1 kg per liter, and mass can be calculated, density must multiply the volume, it will give 1000 gram, and the number of moles, that is mass divided by number molar mass. So mass divided by molar mass, it will give 55.55 mole. This is the number of mole, and molality can be calculated by, that is the number of moles, 55.55 divided by V2 solvent in kg, that is 1, and it will give 55.5. This is the correct answer to calculate the molality of a pure water. Okay. Now next question, which of the following aqueous solution should have the highest boiling point? As we know, that in case of boiling point, for example, option 1 molar NaOH solution, second 1 molar sodium sulfate solution, third 1 molar ammonium nitrate, and fourth has article 1 molar potassium nitrate. As we know, in case of highest boiling point, if we have the different solution having the same molarity, that we see the I value, I, that is a water factor, that is calculate the number of ions formed in each. In case of NaOH solution, that is a 2 ions form, and in case of sodium sulfate there is a 3 ion form. Here ammonium nitrate again 2 ion form, and in case of potassium nitrate again 2 ion form. 2 ion one, more the number of ions and more will be the boiling point. And in case of sodium sulfate, that is a formation of 3 ions, I value is greater, and hence this is the correct answer. Now next question is, the molten sodium hydroxide conduct electricity due to the presence of, first option है free electron है, second है free molecules है, third है free ions है, fourth है atoms of the NaCl and the correct answer, that is a free ions, क्योंकि मोल्टन स्टेट ਦੇ ਵਿੱਚ ਜਿਹੜਾ ਹੈ NaCl ਉਹ ਆਇਨ ਦੇ ਵਿੱਚ ਬ੍ਰੇਕ ਹੋ ਜਾਂਦਾ, ਆਇਨ ਕਟਾਇਨ ਤੇ ਆਇਨ ਦੋਨੋਂ ਬਣ ਜਾਂਦੇ ਤਾਂ ਉਹ ਫ੍ਰੀ ਆਇਨ ਹੋ ਜਾਂਦੇ, that will conduct the electricity. Now next is the units of conductivity, and unit of conductivity is first option है ohm inverse, second ohm inverse centimeter inverse, C option है ohm inverse square centimeter square equivalent inverse, D option है ohm inverse centimeter square, and the correct answer, that is a option B ohm inverse centimeter inverse, that is a conductivity the unit. And number of Faraday required to produce the 1 mole of MnO4 to Mn2 positive ion. ਸੋ ਇਸ ਨੂਮੈਰੀਕਲ ਨੂੰ ਜਿਸ ਤਰ੍ਹਾਂ ਆਪਾਂ ਸੋਲਵ ਕਰਦੇ ਹਾਂ, ਆਲਰੇਡੀ ਆਪਾਂ ਜਿੰਨੀਆਂ ਵੀ ਪਿੱਛੇ ਵੀਡੀਓ ਬਣਾਈਆਂ ਸੀਗੀਆਂ ਇਹਨਾਂ ਚੈਪਟਰ ਦੇ ਬੇਸ ਦੇ ਉੱਤੇ, ਉਹ ਸਾਰੇ ਉਹਦੇ ਵਿੱਚ ਵੀ ਸੋਲਵ ਕੀਤੇ ਸੀਗੇ ਆਪਾਂ ਸਾਰੇ. ਨਾਓ ਲੈਟਸ ਸੀ ਹੈ MnO4 to Mn2 positive, and in case of MnO4 1 negative, and calculate the oxygen state of manganese. So x 4 to x plus 4 into 2 minus 8 equal to -1, it will give +7, and here is +7 to form manganese 2 positive ion, it means there is a 5 electron changes in the oxidation state, and hence Q is equal to NF. As calculate the number of Faraday required, as N value is 5, and hence answer is 5F. Now let's see the option. First option 5F, second option 2F, third option 1F, and fourth option 7F, and the correct answer, that is a 5F is the option A option. ठीक है जी. Now next question है again electrochemistry chapter ਦੇ ਉੱਤੇ numerical है the limiting molar conductivity of NaCl, Kb, potassium bromide, KCl are 126, 152 and 150 and respectively calculate the molar conductivity for the NaBr. As we know, in case of NaBr, to calculate NaBr, in case of NaBr calculate, so first NaCl and KBr, if we add the molar conductivity of NaCl and KBr and subtract the KCl molar conductivity, that will give value, that is a 128 Siemens centimeter square per mole, and the correct option is first option है 128 Siemens centimeter square per mole. Next question, the rate constant of a reaction is 3 into 10 raised power -3 mole inverse liter second inverse. What is the order of a reaction? And if we calculate the order, we have given the value, so directly we can calculate easily the order of a reaction by their units. And as we know, the units can be calculated for the rate constant. This is concentration, that is mole per liter, power 1 minus n, and second inverse, put the value of turn by turn for zero order and value 0, and for first order and value 1, and second order and value 2, we will get the directly the order of a reaction. So here is order of a reaction is option 1 1, option 2 2, and 3 option C option, and D option that is a 0, and the correct answer is a 2 order second order reaction. Now next question, the unit of rate constant for a zero order reaction. Again, the unit of a rate constant for a zero order reaction can be calculated by again use the previous formula to calculate the rate constant for zero order reaction, and the correct answer option first option second inverse second mole liter inverse second inverse, C option mole inverse square liter square second inverse, and D option mole inverse liter and second inverse, and the correct answer is mole liter inverse second inverse. Next question is the rate of a catalyst is to change. First option is activation energy of a reaction, second is equilibrium constant, third is Gibbs energy of a reaction, and fourth option enthalpy of a reaction, and the correct answer is activation energy of a reaction is the correct answer. Next question is that in the reaction A to B product, if the B is taken in excess, then it is an example of, अगर कोई भी साढ़े कोल रिएक्शन है तो बी ਉਹਦੇ ਵਿੱਚ ਟੇਕਨ ਕੀਤਾ ਜਾ ਰਿਹਾ ਐਕਸੈਸ ਦੇ ਵਿੱਚ, ਤੇ ਉਹ ਸਾਡੇ ਕੋਲ ਜਿਹੜੀ ਰਿਐਕਸ਼ਨ ਹੈ ਉਸ ਰਿਐਕਸ਼ਨ ਦਾ ਨਾਮ ਕੀ ਹੋਏਗਾ? ਫਸਟ ਆਪਸ਼ਨ ਹੈ ਸੈਕਿੰਡ ਆਰਡਰ ਰਿਐਕਸ਼ਨ, second option zero order reaction, third option pseudo first order reaction, and fourth option that is a first order reaction. As we know the definition of the pseudo first order reaction, if we taken is one substance is in excess, then this is a pseudo first order reaction, which is actually that is a first order reaction but appear to be second order reaction. And next question, MCQ from the coordination compound chapter, the IUPAC name of K3 FeCN5NO is. First option है potassium pentacyano nitrosyl ferrate, 2 option potassium pentacyano ferrate 2, third option है potassium pentacyano nitrosyl ferrate 3, and next option है potassium pentacyano nitrosyl ferrate 2. And if we calculate the oxidation state, it will we will get the two oxidation state, and the correct answer is potassium pentacyano nitrosyl ferrate 2 is the correct answer. Now next is Cn negative is a strong ligand. This is due to fact that it carries a negative charge. Second option, it is a pseudo halide. C option, it can accept electron from metal species, and fourth option, it forms a high spin complex with the metal species, and it is a pseudo halide, so this is the correct answer. And next question is ethylene diamine is an example of which is also written as ene form, ठीक है जी. And first option है monodentate, second है bidentate, third है tridentate, fourth option is a polydentate. As we know in ethene, that is a formula CH2 NS2 and NS2, both NS2 having a nitrogen, and nitrogen both having tendency to donate the electron pair to the central metal atom. So two types of nitrogen are present and two coordinate bond can be formed, and hence it is a bidentate ligand. Next a ligand can also be regarded as first option है लुईस एसिड है, सेकंड है ब्रोंस्टेड बेस है, थर्ड है लुईस बेस है, एंड फोर्थ है ब्रोंस्टेड एसिड है. सो करेक्ट आंसर लिगेंड कैन आल्सो एक्ट एज ए लुईस बेस, ठीक है. सो लास्ट क्वेश्चन है द कोऑर्डिनेशन नंबर ऑफ ए क्रोमियम इन CrNH3 thrice water 3 Cl3 is. We calculate the coordination number by considering the chromium as a X, NH3 that is a neutral ligand 0, water is also a neutral ligand 0, and Cl3 this is a negative ligand, and total coordination number option A is 3, B option 4, C option 6, and D option is 2, and the correct is the coordination number is a number of ions that will join to the central metal atom, that is a ligand number of ligand in the close bracket. Total NH3 3 है, water also 3 है, total हो गए 6, and hence coordination number is 6. So This is the way to solve the MCQ. Next question is true false questions. Double salt exist in only in the solid state. So double salt ਜਿਹੜਾ exist ਕਰਦਾ ਹੈ only in the solid state, that is a true statement, because ਜਿਹੜਾ complex salt ਹੈ ਉਹ exist ਨਹੀਂ ਕਰੇਗਾ solid state ਦੇ ਵਿੱਚ. Next ਹੈ oxalate ion is monodentate ligand. No, this is oxalate. In case of oxalate, COO negative is COO negative. This is a two types of coordinate bond. It is a bidentate, so this is a false statement. Next, the molten NaCl conduct electricity due to its free ions. That is a true statement, already discussed in the MCQ questions. Next question, the efficiency of fuel cell is 80%. This is false, and the correct option, that is a 60%. Next, a coating of zinc from the protection of corrosion is called galvanization process. We कह दिन्ने ਆਪਾਂ ਇਹਨੂੰ ਤੇ coating of zinc ਵੀ ਕਰ ਦਿੰਨੇ ਆ steel ਦੇ ਉੱਤੇ ਵੀ, that is also a galvanization process. So this is a true statement. Now next is 2 marks questions, section B. First question is give the difference between ideal and non-ideal solution. Ideal solution, so answer is they obey Rolle's law, where all condition of temperature pressure applied and they do not obey Rolle's law. Second, the attraction interaction between the components of a solution of a same magnitude as those of pure component, same, and the attractive interaction between the component of solution are different than those of in pure complex. There is no change enthalpy change. There is enthalpy change, that is delta H mixing is 0 and near delta V mixing is 0. Here delta H mixing doesn't 0, delta V mixing doesn't 0. Example, ethanol and water, and a non-ideal solution, that is water, nitric acid, and acetone is a chloroform. Now next question is state and explain the briefly Henry law. The law states that the mass of a gas dissolved in a given volume of a liquid at a constant temperature is directly proportional to the pressure of a gas present in equilibrium with the liquid. Mathematically, M is directly proportional to P. M is the mass of gas dissolved per unit volume of a solvent, and P is the pressure of a gas in equilibrium in a solution. That can also written as P is directly proportional to XP. If we remove the proportionality constant, we will get the P is equal to KH. XV, KH is a Henry constant. So according to Henry law, the partial pressure of a gas over the solution in which the gas is dissolved is directly proportional to the mole fraction of a gas. Now next is numerical based question. Numerical from the solution chapter. 18 gram of glucose having the molar mass 180 gram per mole is dissolved in 1000 gram of water in a solution. At what temperature will the solution boil? Kb for water is 0.52 Kelvin kg mole per mole, and boiling point of pure water is 373.15 Kelvin. And let's solve the question. Write the given statement. Always use the stepwise method to solve the numerical. First, write on the given statements, then write the formula from which the given statement and the to find the statement are present, then solve the numerical by using the formula. First है WB, that is a mass of solute 18 gram है. Total molecular mass, that is a 180 gram. WA, that is weight of solvent है 1 kg, which is equal to 1000 gram. KB is given, TB is also given, TB note. So TB is calculated. So first, by using the colligative property statement, delta TB equal to KB into M, elevation in boiling point. So calculate the delta TB value by putting all the values. We will get the 0.052 Kelvin by using the relationship delta TB equal to TB minus TB naught, and TB can be calculated, that is a boiling point of pure water. TB is TB naught, boiling point of pure water. TB naught 373.15 is already given, so TB can be calculated easily. So second question or option, addition of 0.643 gram of a compound to 50 ml of benzene and given density is 0.879 gram per mole lowers the freezing point from 5.51 degree centigrade to 5.03 degree centigrade. If Kf is 5.12 Kelvin kg per mole, calculate the molecular mass MP. So write the given statement. WV is 0.643 gram, and density formula is mass per unit volume. So here mass can be calculated as a, it will give them density multiple the volume, it will give 43.95. so calculate the MB value by using the relationship delta TF is already given, that is equal to 5.51 delta TF naught minus TF 5.03, it will give the 0.48 degrees centigrade. So delta TF, again colligative property relationship of the depression freezing point, delta TF equal to KF into M, and delta TF can be solved by putting the all the values, and MB can be calculated here and put all the value, we will get the 156 gram per mole. So next numerical, that is from the electrochemistry chapter, the molar conductivity of infinite dilution for a sodium acetate CS3CONA, hydrochloric acid HCl, and sodium chloride are 95.5, 426.9 and 120.4 Siemens centimeter square per mole respectively at 298 Kelvin. Calculate the molar conductance of a acetic acid at infinite dilution. This is a numerical based upon the Coleridge law. So given statement are given here, right here, sodium acetate HCl and NaCl. By using the Coleridge law, acetic acid molar conductivity can be calculated by sum of the molar conductivity of sodium acetate and HCl and subtract from the NaCl. We will get the value that is equal to 399 Siemens centimeter square per mole. So next question is, what is the amount of electricity required to deposit 1 mole of calcium from the molten calcium chloride? So calculate the amount of electricity. So first write down the equation. Answer is calcium chloride, which is written as equation calcium 2 positive plus 2 Cl negative ion. So calcium 2 positive ion, by gaining the 2 electron, it will form a calcium, that is a 1 mole. So to deposit 1 mole of calcium exactly required, that is a 2 electron. So 2F Q is equal to NF and N value is 2, and F, that is a Faraday constant, that is a 96500 value. Put the value and calculate its answer easily. Now next question is, that is from the chemical kinetics. If first order reaction is found to have a rate constant equal to 5.5 multiple 10 raised to minus 14 second inverse, and find out the half-life of a reaction. This is a very simple question. By using the equation for a first order reaction, by using half-life period equation, T half equal to 0.693 over K, and put the value of rate constant here and solve it, it will get the value, that is a 1.26 multiple 10 raised to 13 second, that is a half-life period for a first order reaction. Now our option is question again from the chemical kinetics, that is the reaction between the NO2 and CO to give a carbon dioxide, and NO takes place by following the mechanism NO2 plus NO. This is a slow reaction, it will give NO plus NO3. Second reaction, second step, NO3 plus CO, it will be fast reaction and form a CO2 plus NO2, and the overall reaction is given as NO2 plus CO to form a CO2 plus NO. Write the rate expression and order of a reaction. What is the unit of a rate constant? So as we know that in case of different types of reaction are present, then slow step is the rate determining step. So by using the rate expression, rate can be rate constant, rate of reaction can be written as equal to the K multiple by concentration of the reactant side, K multiple that is a NO2 and NO. So NO2, it will give a rate equal to K NO2 square, and the overall order of a reaction, that is a 2 terms, this is a 2, and the unit of a rate constant of a second order reaction is, as we know, mole inverse, second inverse, and liter is the correct answer. So next question, that is given the difference between the double salt and a coordination compound. Double salt and coordination compound, then this is NO. Double salt and coordination compound, that the first, that is a double salt, they exist only in the solid state. In aqueous solution they dissolve completely into ions and complex compound, that is they exist in solid as well as in the aqueous solution. This is because even in the solution the complete ion doesn't dissociate into the ions. So next point is the usually double salt, they usually contain two simple salt in equimolar properties, and the complex compound, the simple salt from which they are formed or may not be equimolar proportions. And the third point, the properties of a double salt are same as those of the constituent compound. And the third option here, complex compound, is the properties of a coordination compound are different from the constituent. In the double salt, the metal ions show their normal valency, and in the coordination compound, metal ions satisfied two types of valency, that is the primary and secondary valencies. And double salt lose its identity in the solution, and the coordination compound retain its identity in the solution. So ये सीगे साडे क्वेश्चन. नेक्स्ट ਆਪਾਂ ਕਰਦੇ ਹਾਂ numerical. Again numerical, and that is from the electrochemistry. The molar conductivity value at infinite dilution value of NaCl and KCl are 126.5 and 149.9 ohm inverse centimeter square mole inverse respectively. The ionic conductance of Na positive ion at infinite dilution is 50.1 ohm inverse centimeter square per mole. Calculate the ionic conductance at infinite dilution for K positive ion. Write down the first given statement, all the three given statements. So to calculate the K positive ion, so it can be calculated by subtracting the value, that is from KCl and NaCl value, molar conductivity value. So put the value of KCl and NaCl subtracting, and plus the value, that is a Na positive ion, we will get the value, that is a potassium positive ion. So this is the numerical from the electrochemistry. Next question is the give the difference between the DNA and RNA. Again this is a biomolecular question. It consists of two chains of nucleotides which are coiled around each other to form a double helical structure, and RNA, it consists of a single chain of a nucleotide which is so longer that it twists and coiled around itself to give a double helical structure. Okay. And next that is a sugar present in DNA is a deoxyribo sugars, and sugar in RNA is a ribo sugar. The next point is the pyrimidine present in DNA only are the thymine and cytosine. The pyrimidine is present in RNA are uracil and cytosine, and DNA occur in the nucleus of the cell, and the RNA it occurs in the cytoplasm of cell. DNA molecules are longer in size, and RNA they are smaller in size. Next question, again biomolecule. What is the chemical name and deficiency disease of a vitamin C? And the answer is chemical name, that is a ascorbic acid, and deficiency disease, that is a scurvy pyorrhea or bleeding of gums. Okay. Now next, that is a write the IUPAC name of a given compound. Two compound are given. First is NaAuCN twice, and oxidation state first we calculate consider sodium, that is a 1, and by using the x value of Au, it calculate the value, it will give a 1, and the IUPAC name is sodium dicyanoaurate 1 oxidation state. Similarly for the second, calculate the oxidation state, that is a 3, and write the IUPAC name potassium trioxalatoferrate 3, that is the IUPAC name. Now next is the section C, 3 marks questions. First write down the equation and calculate the EMF of a cell at 298 Kelvin. Given statement is magnesium 2 positive ion, and concentration is given here. Salt is again copper 2 positive ion, molar concentration and copper solid, and given statement of reduction potential E naught of magnesium 2 positive to magnesium is minus 2.37 volt, and E naught value of copper 2 positive to copper is 0.34 volt. So write down first to write down the Nernst equation. First write down the equation at anode oxidation half cell reaction, and at cathode, that is reduction half cell reaction. So at anode oxidation, magnesium to magnesium 2 positive ion plus 2 electron. At cathode, that is a copper 2 positive to copper. Overall reaction, it will give a magnesium plus copper 2 positive, magnesium 2 positive plus copper, and here n value is 2 because 2 electrons are used in both the equations. So reduction potential value are given. So first we calculate the E naught cell, that will become equal to E naught cathode minus E naught anode. So write down the reduction potential value of both the copper 2 positive to copper and magnesium 2 positive to magnesium, and calculate the E naught cell will become equal to the 0.34 minus 2.37. It will give value this. Now next is E naught cell can be calculated as 2.71 volt. So according to Ryder's Nernst equation, E cell equal to E naught cell minus 0.059 over n log magnesium 2 positive over copper 2 positive n. Put the value of n equal to 2 and E cell. So Nernst equation can be written as E cell equal to E naught cell minus 0.059 over n log molar concentration of product over molar concentration of a reactant, and n value is 2. So equation can be written as E cell equal to, put the value of E naught cell 2.71 and calculate, put the value of magnesium 2 positive and concentration value and solve it. We will get the E cell value is equal to 2.68 value is the answer. So similarly with our option, again calculate the E cell and delta G for a cell copper to copper 2 positive 0.130 molar, Saltwich Ag positive to Ag 1 multiple 10 to the power minus 4 molar, E naught copper 2 positive to copper equal to 0.34 volt, and E naught silver positive to silver, that is 0.80 volt, and given F value, that is a 96500 coulomb, and R value equal to 8.314 joule per Kelvin per mole, and E naught value copper 1 positive to copper equal to 0.34 volt. And given statement at anode, write copper to copper 2 positive plus 2 electron. This is the oxidation of cell reaction. At a cathode, that is a reduction of cell reaction, Ag positive to gaining the electron to form a Ag. To calculate the overall cell reaction, first we multiply by 2 to form a equal, that is a 2 electron here, and to form here 2 electron by multiplying the second equation by 2. So overall reaction is copper plus 2 Ag positive plus copper 2 positive plus 2 Ag, and here n value is 2, and so write down the first E naught cell reaction is equal to E cathode minus anode. By put the value, it will give the 0.46 value. So next is, according to Nernst equation can be written as E cell equal to E naught cell minus 0.059 over n log molar concentration of product over molar concentration of a reactant, and E cell by put the all value here and solve it. This is step by step method. By calculating the E cell is equal to 0.25 volt. So now calculate the delta G value. Delta G will become equal to relationship minus NF E naught E cell. So by put the value of all, and we will get the delta G value is equal to minus 48.250 kilojoule per mole. So next question is, the rate constant for a first order reaction is a 90, and how much time, 90-second inverse, and how much time will it take to reduce the concentration of reactant to 1/20th of its initial value, and K is 90-second inverse, that is the initial concentration. Let the initial concentration A and concentration of reactant is reduced to 1/20th of its initial value, so A minus X become equal to 1/20A. By using the relationship for the first direction, T 1/20 equal to 2.303 over K log initial concentration A final A minus X. So put the value here, we will get the value T 120 will become equal to 0.0333 second. This is the correct answer. Now calculate the time required for a completion of a 90% of a reaction for a first order kinetics, and the T half will become equal to 44.1 minute. So T half is given here. By using the relationship, T half become equal to 0.693 over K. So when 90% of reaction is complete, then X is 90% of A, and X become equal to 90 over 100 multiple A, 9 over 10 A. X is B reacted concentration, and A is initial concentration. So by using the again formula, first order reaction, T is equal to 2.303 over K log A over A minus X. Put the all the values and calculate T 90% value. It will give the T 90% equal to 2.303 over K log 10. It will, so divide the first equation and second equation. So T 90% or T half, it will give the value that will become equal to T 90% equal to 3.323 multiplied by T half, and put the value, it will give T 90% 146.54 minutes. Okay. Now next is 15 question है, write the Nernst equation and calculate EMF of a cell at a 298 Kelvin. So example is here given, nickel to nickel 2 positive and 0.01 molar, and copper 2 positive to copper 0.01 molar, and given E0 cell, both reduction potential copper 2 positive to copper and nickel 2 positive to nickel are given here. And so first of calculated by the E0 cell, that is the E cathode minus E anode, put the value and solve the value. E0 cell become equal to 0.56 value. So write down the Nernst equation. At anode, oxidation half selection is nickel to nickel 2 positive plus 2 electron, and cathode copper 2 positive plus 2 electron to form copper, and overall reaction is given here. And E cell become equal to Nernst equation can be written as E cell equal to E0 cell minus 0.059 over N log concentration of product over concentration of a reactant, and put the value here and solve it. E cell become equal to 0.56 volt. This is the correct answer. Now next is the section D. 5 marks question are coming here. So section D, that is a 5 marks question. First question है, the transition, this is from the D block elements, the transition D and F block element, the transition metal and their many compounds act as a good catalyst. Second question है, transition metal form a number of interstitial compound, explain. So first question answer is transition element act as a catalyst because of the following reason. First, due to presence of unpaired electron, transition metal possesses a capacity to absorb and emit wide range of energies. By doing so, transition metal makes the energy required of activation available. Second point, transition metal shows variable oxidation state. These may form intermediate compound with one of the reactant. Their intermediates provide a new path having lower activation energy. Third point, transition metal also provide a suitable large surface area for the free valencies so that reactant can be easily absorbed. Now next is, for example, vanadium pentoxide V2O5 as used as a catalyst for the manufacture of sulfuric acid in the contact process, and finally divided iron in the manufacture of ammonia in the Haber process. This is a catalyst. So second question answer is, interstitial compound are those compounds which are formed by the small atoms like hydrogen, carbon, boron and nitrogen that are easily trapped inside the crystal lattice of the metal, and they are generally non-stoichiometric and are neither typically ionic nor covalent. For example, titanium, carbon, manganese, nitrogen, iron hydride, and the transition metal form a large number of interstitial compounds because of a small atom of the certain non-metallic compound hydrogen, boron, carbon, nitrogen, etc. get trapped in the void of the lattice, example the transition metal atoms, and as a result of filling of the interstitial sites or species, such interstitial compounds are hard and rigid. And the option question are, why transition element forms a colored compound, and second question is, why transition metal forms alloy with the other transition metal easily. And the first answer is, the color of the compound of a transition metal may be attributed due to the presence of incomplete N-1d subshell. In case of compound of transition metal, the energy of 5d orbital same subshell do not remain equal. Under the influence of approaching the ions, the ligand toward the central line, and d orbital, that is the central metal ion, split into two different energy levels. The phenomena is called as a crystal field splitting energy, and they, as in this case of transition metal ion, the electron can be easily promoted from one energy to another energy, and same d subshell, these are the These are called as a DD transition. As a result of transition, element form a colored compound. Example is here as a 5 d block element that is separated into the two levels, higher energy and lower energy, dxy, dz, dzx, and dx square minus y square and dz square. And when electron by gaining the energy move to the higher energy state, as the higher energy state become unstable, the electron fall into ground state to gain the stability. Then energy which is absorbed by the d block elements, that is fall into the visible region, and that will show the color. Second question is the tendency of transition metal to form alloys can be explained on the basis of atomic size, and atomic size of the transition metal are very similar, and hence the crystal lattice atoms of the one metal can be readily replaced with the atom of another transition metal, and the result in the formation of alloys. For example, steel iron alloy with carbon and alloy are generally harder and having high melting point and more resistant to corrosion than that of individual metals. So this is the first question which is optional. Second question again from this chapter, why transition metal exhibit a large number of oxidation state, and second question define lengthened contraction and also explain the cause of lengthened contraction. So answer of first question is that the transition metal have their valence electron in the two different sets of orbital, that is n-1d and ns. The variable oxidation state element is due to the availability of both n-1d and ns electron. And for the bond formation, as the energy of these d orbital and the ultimate s orbital are nearly same, since there is very little difference in energy of this orbital, and both energy level can be used for the bond formation. The sum of total of ns and unpaired n-1d electron determine its oxidation state, shown by the transition metal as a iron 2 positive and iron 3 positive, iron 4 positive, iron 5 and 6, copper 1, copper 2, chromium 1, 2, 3, 4, 5, 6, and manganese 1, 2, 3, 4, 5, 6, 7, as we show the different oxidation state due to availability of a d electron. And the second answer is in lengthened. What is the lengthened contraction? That in lengthened series, with increasing the atomic number, there is a progressive decrease in atomic as well as ionic radii of a trivalent ion. As we move from lanthanum La3 positive to Lu3 positive, and the regular decrease in atomic and ionic radii with increase in atomic number is called as a lengthened contraction. This is shown in graph. Here is ionic radii and atomic radii. This is a decrease in atomic and ionic radii, and the cause is lengthened contraction is due to the increase in effective nuclear charge. As we move along the lengthened series, the nuclear charge by one unit and one electron is added in 4f subshell is very poor. Because of its diffused shape of f, there are effective nuclear charge experienced by each 4f electron increase, as a result of which the 4f electron subshell contract at each successive element. The lengthened contraction occurs and size starting the decreasing. So optional question are, why transition metal have tendency to form complex compound, and second what are the consequences of the lengthened contraction. So answer of first question is, the transition element form a complex because of the following reason. First, compatibility of the smaller size of their metal ions. Second, their higher ionic charges. Combining of 1 and 2, we can say that high charge density of the orbitals can accept one or more electron pairs from the ligands. So because of the presence of vacant n-1d orbital, and so the orbital can accept one more electron pair to form a from the ligand. And for example, Cu water 6 3 positive, CuNH3 4 2 positive, and iron FeCN6 4 negative, etc. Next, that is the consequences of lengthened contraction. First, lengthened contraction result in the similarity in the size of element belonging to the same group and same group of second and third transition series. Second, due to lengthened contraction, the charges In the ionic radii of lanthanide, ion is very small, as a result of which their chemical properties are similar. This makes the separation of the lanthanide difficult. Third option, due to lanthanide contraction, the size of the lanthanide ion decreases from La3 positive to Lu3 positive. The covalent character of a hydroxide ion increases, and hence the basic characteristic decreases, and thus the LaOH thrice is the most basic, then LuOH thrice is least basic. So fourth point, due to the lanthanide contraction, the electronegativity increases from the element lanthanum to lutetium. So these are the all the most important question of all the chapters which are present in the September examination, and all the best to all the students, and please like, share and subscribe. Thank you so much.